This is part 4 of section R.8, nth roots and rational exponents. When radicals occur in quotients, it's customary to rewrite the quotient so the new denominator contains no radicals. So if you work out a problem, you end up with a radical in a denominator, you're not done. It's kind of like simplifying a fraction. You have to keep going. And we're going to learn how we fix this. This process is referred to as rationalizing the denominator. The idea is to multiply by an appropriate expression so the new denominator contains no radicals. So here we're just going to practice with what if our denominator was these options. What would we multiply by to get these results? Okay, so this is if our denominator contains. We're not actually rationalizing a denominator yet, we're just practicing. What would you multiply the square root of 3 by in order to get rid of the radical? Well, the smallest and easiest thing would be to multiply by the square root of 3. Why? Because according to our properties, if we multiply the square root of 3 times the square root of 3, we get the square root of 3 squared, which is what? 3. And now we have no radicals. Okay, this one's a little different. What if we multiply this? We have a denominator that has the square root of 3 plus 1. Well, let's look at see what happens if we multiply. Well, let's remember something. We have seen before when we were factoring and we saw the difference of squares, and we saw that if you had a plus b and you multiplied by a minus b, what happens? You got a squared minus b squared. If we square a square root, we don't have a radical anymore. So we would like to do that. So, but if we multiply by a plus b times a plus b, of course we get a middle term, and our middle term would have radicals. So let's multiply this by square root of 3 minus 1. So what happens? First times first, square root of 3 squared, right? First times first. Outside times outside will be negative square root of 3. Inside times inside will be positive square root of 3. And 1 times negative 1 will be negative 1. Well, what's the square root of 3 squared? Of course, that's 3. And so now our new denominator, if that had been our denominator, our new denominator would be 2. So, along the same lines then, what do you think we're going to multiply square root of 2 minus 3 by? The square root of 2 plus 3. Correct. Square root of 2 times square root of 2. I'm going to write it this way this time because it's the same thing. Square root of 2 squared, same as writing it like that. First times first. Then we'll get a positive 3 square root of 2 and negative 3 square root of 2. Those cancel. Negative 3 times positive 3 is negative 9. So what do we get? Square root of 2 squared is the same as the square root of 4, which is 2. 2 minus 9 equals negative 7. It's a negative, but it's not a radical. It's free of radicals. All right, pushing it a little further, what do you think we multiply this by? Well, I'm sure you said square root of 5 plus the square root of 3. Because what have we done every time? Change the sign. That's it. These are called conjugates. If you multiply by the conjugate, then you get rid of that middle term. All right, first times first, we get the square root of 5 squared. And then, of course, we know the middle's going to cancel, and then it's going to be minus because negative times positive, square root of 3 squared. So what's that? 5 minus 3, or 2. Again, we got rid of the radicals. Okay, here's the last one. It's a cube root problem. The cube root of 4. If we wanted to make that a perfect cube, I mean, that's what we did here. We made that a perfect square by multiplying 3 times 3 and getting 9. To make this a perfect cube, well, let's remember what were the perfect cubes. 2 cubed was 8, and 3 cubed was 27, and so on. Well, can I multiply 4 by something to get 8? Sure. So if I multiply by the cube root of 2, then what happens? Remember our rules for radicals said we can just multiply that and get the cube root of 4 times 2, or the cube root of 8, which is 2. Okay, so in rationalizing the denominator of a quotient, be sure to multiply both the numerator and the denominator by the expression. So we weren't really working with a full fraction. We were just pretending, what if our denominator looked like this? But they're in a fraction, they would also have a numerator. We have to multiply the top and bottom by that. The top and bottom by this, 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 and this. And we may end up with radicals in the numerator, but that's okay, because the whole point is just you can't leave your answer with a radical in the denominator. So now we'll practice that in the next video.